Problem number 7, we want to review solving a right triangle. So I want to find all the missing angles and sides. The missing angle is pretty easy. I know that the 22 and the alpha must add up to 90 since that third angle is 90. So all I would have to do to get that is just subtract 90 minus 22. That's going to come out to be 68 degrees for angle alpha. And then what about side A and side C? I think I'll have to set up a trig statement. For example, I could say sine of 22 degrees is equal to 12 over C. And then I can solve this for C and have my solution. Multiply both sides by C, and then I'm going to have to divide both sides by the sine 22 degrees, and that's going to give me C is 12 over sine 22. Well, that's something I can work out on the calculator. I am in degree mode, so I can just type it in, 12 over sine 22. And to one decimal place, that comes out to be 32.0. The only other thing I need is side A, and I have a choice here. I could write another trig statement, or I could just use the Pythagorean theorem. So I'll have a squared plus 12 squared equals that 32.0 squared. Of course, when I work this out, I'll want to use the full value from the calculator. A squared will be that 32.0 number squared minus 12 squared, and then take the square root of each side, and I'll have it. That's what I want to type into the calculator using that full value. So open up the square root, take that last answer, the 32.0 number, and square it. Important to use all the digits, minus the 12 squared, and that gives me the value I want, 29.7. And that's it. We found all the missing pieces. Let's try again in number 8. Now this one's a little different because I don't know either angle, so I'll have to think about that. I do know 2 of the sides, so I can start by finding side A using the Pythagorean theorem. A squared plus 7 squared would be 15 squared. That would be a squared plus 49 equals 225. Subtract the 49 and you're going to get 176. And so all I need to do is square root 176, and I have my value of A. Square root 176. Looks like about 13.3. Of course, if I use that answer later in this problem, I'll want to keep all those digits long. Now, how will I find one of these angles? Well, I'm going to have to use trig. I can set up a nice trig statement. I think I'll use the numbers that were provided. So, for example, I could write sine of beta is equal to 7, the opposite, over 15, the hypotenuse. I can see that beta is an acute angle. Well, that means the inverse trig function will give me what I want. Inverse sine of 7/15 is going to tell me angle beta, and that I can get right off the calculator. Sine inverse 7/15 gives me in degrees 27.8 degrees. And that's really the only trig that I needed to do. Angle alpha, the last angle, I can get by simply subtracting that 27.8 from 90. I know that those two angles together add up to 90 degrees. 90 minus that last answer gives me 62.2 degrees. And once again, we are finished. Problem number 9. I want to find the measure of each angle, and notice we're not worrying about the positive and negative thing here, the direction of rotation. I just want the amount, the measurement of the rotation. I just need to use some geometry. Let's see, I have this big angle here that's 206. I want the leftover if I had gone all the way to 270. Right? All the way to here would have been 270. So all I need to do is 270 minus the 206. That's going to give me 64 degrees for that little leftover portion. Okay, let's look at letter B. There's a couple of different ways you can do this one. This angle here is 42 degrees. Well, that should make it pretty easy for me to find this angle here because I can tell that those two angles together must add up to 90. That would make this 48 degrees. 42 plus 48 is 90. But then 48 and angle beta must also add up to 90 because they're the other two angles in this right triangle here. So to get angle beta, if I just subtract 90 minus that 48, I'll have it. Now what that comes out to be is 42 degrees, which means really there was an easier way that I could have approached this as long as I remember some geometry. From geometry, when you have two parallel lines cut by a transversal, meaning just another line that runs them through, the alternate interior angles, this one here and this one here, are congruent. They have the same measure. So for sure, angle beta is 42 degrees. And then letter C, I think, is like letter A. This big angle here stopped 31 degrees short of going all the way to 270 degrees, 90, 180, 270 if it had gone all the way to there. So if I just subtract 270, take away 31, that'll tell me what that big angle is, and that comes out to be 239 degrees. Problem 10, I want to solve the equation for theta. I know that theta is acute. That's nice because then I don't really need a picture. I know it's just a first quadrant angle. I am measuring in degrees here, and we are giving a rounded answer. Well, in part A, there's nothing really to do except go to the calculator. I know I'm in the first quadrant, which means I can find theta using the inverse sine function. Just take inverse sine 4/11 and you're done. Sine inverse 4/11 comes out to be 21.3 degrees. Letter B should be similar. I just need to do some cleanup first. Let's cross multiply. So I have 12 sine theta equals whatever 4.7 times 2.3 is. And then I'm going to divide both sides by 12. That gives me sine theta equals 10.81 when I multiply those two decimals divided by 12. I don't want to do that division because the problem says don't round until the very end. So I don't want to have any rounding errors. I'll just keep it like that. Once again, I know I'm in the first quadrant, so my theta is just going to be the inverse sine function of that ratio. And even though it's a little bit of a mess, the calculator won't care. You can just type that in. Sine inverse of 10.81 over 12 comes out to be 64.3 degrees. Since we know that we're only looking for an acute angle, that is the only solution to this equation.